Yeah, so the decoded pattern by the AI are also described as the numeric values, giving us a novel perspective by converting the discrete and static entities into more the transitional and continuous morphology. So this is a 2D version of the generative adversarial network, which is called GAN, and it captures the same architectural elements in different typologies and then find some hidden patterns, and finally traverse different typologies visually. And this concept could be also extended to the 3D dimension as well. So for instance, by training lots of the 3D chair, AI learns the morphological features of chair, and the functional morphologies are rebuilt here, that is, such as 4 legs or leg-like structures to support the flat surface. So it means that the form of a chair reflects its function. Also, 3D GAN allows us to see the transition, so it helps us trace the morphological changes more easily. So the final output of the unit might present architecturally functional morphology and its texture or some of the material if possible.
So the primary goal of this year's workshop is in identifying functional morphologies. For example, these pictures reveal how different columns were used for support throughout different eras in Korea. Running 3D GAN on these columns will yield functional morphologies that will provide an insight into how Koreans reflect function into forms. Next, please. The students were asked to identify the function of their choice with a definition for a more precise collection of data. The data set is then analyzed to yield different morphologies reflecting their Koreanness. Next, please. Using derived functional morphologies, students will be asked to design House Korea. The end product is not, which is going to be our end product, and the end product is not a real-life design, but an assembly of Korean design thinking and forms that serves function. Next, please. The students are currently at 2.1 phase, or phase 2.1, and they've identified their functions they want to investigate and define them. And the definition of each function was then used to create a data set, which was run through 3D GAN. The result you will see are most likely to be a trial run of final functional morphologies. Thank you.
Thank you.
Yeah, so we're gonna start our student presentation. So it's going to be one.
Yeah, we're gonna start with Jiaxin. So
hello everyone. We are a group from Unit4 Elemental Subtouch, and I'm Jiaxin, and my teammates are Heijin and Kite. So each group member have done research on different fundamental architecture elements from the traditional Korean houses by collecting 2D and 3D data and then generate models through the machine learning process. Next, please. And my keyword is canopy. The definition of canopy in dictionary is a layer of something that spreads out and covers an area, which is quite common element we can find in nature and our daily lives. For example, the mushrooms, umbrellas, building roofs, and also trees in forest. Next, please. And when taking the Korean traditional houses as an object to observe, it's easy to notice that a canopy covers an area, but doesn't have to be an entire surface. It can be composed by overlapping individual units, which could better perform the protection function. So my definition for canopy would be an assembly of overlapping repetitive architecture elements that create a sheltered space. Next, please. In traditional Korean houses, the giwa means the tile, and there are two types of tiles. The flat tiles applied on the roof, and the curved ones covers the joint between two rows of the flat tiles. And the reason why people use this method for their roof is that it requires minimal maintenance, could withstand extreme weather, and also help stable the indoor temperature. Next, please. Based on the research, the traditional Korean houses can be divided into several types according to their layout. For example, the U-shaped, L-shaped, square, and straight line layout. The square layout mostly built in the cold northern region, while the straight line mostly seen in the warmer south region. And in Asian, the tile roofs are commonly used in Hanok, used by royal families and upper class. Next, please. The tile roofs are still popular choices in Korea in the 80s, which proved the great performance of tile roofs in durability and practicability. Next, please. According to the president, I modeled different types of tile roofs and input as sample model for machine training. Next, please. And these are all the sample models. Next, please. Yeah, next, please. These forms are results that generated from the machine learning. Next, please. And these models are generated from the translation process, which trying to mimic the basic rules it learned from the previous input sample models. Next, please. And that's the end of my presentation. Thank you.
I'm in charge of the flooring part. I define the flooring as a surface that is planned horizontally or vertically to connect space. Through these elements that can be found in traditional Korean architecture include floor, stair, and stepping stones. The Chungmaru is the largest floor which serves as a living room that connects the room and the room. Also, before entering the room, it connects the outside and the inside as a front room. Tenmaru serves as a passage between the outside and the inside. In this way, I defined the flooring in traditional Korean architecture, determined the corresponding elements, and constructed a data thorough modeling. After that, it is searching for a shape through machine learning with 3D GAN.
Hi, I'm Gita Kim, and my keyword is support. The support that I define is a sample of components that resistant to gravity slantly. The building have all the gravitational pull of the earth, and one of the things that hold them up is the support of the roof. I thought it was important to create and maintain three-dimensional space, and in that sense, so I defined the support as shown on the screen. First example is sakare, rafter that supports Korean traditional houses roof to resist gravity. The rafters form various shapes depending on the size of the roof. And also, I think arches belong to the same definition. It plays a role in supporting something above, and it is used in many buildings, such as Gwanghwamun. Lastly, many steel structure supporters were seen in buildings that are currently seen in Korean, such as Yangok or plastic houses. So I made 3D model with this image data, and when the data are in boxes as follows through modeling, the following types of supporters came out. Through those data, I could see that it gradually appeared similar to the data while doing machine learning. And finally, the image that came out through the GAN interpolation is that image. I think the biggest characteristic that came out of it is that it rises and is formed vertically. And I'm going to add more data to extract various results through post-work. Thank you.
Sorry, by the way, I forgot to mention about in our unit schedule. So like we have 4 teams, and each team will have a presentation and discussion presentation. So each team we're going to have 15 minutes. Yeah, something like that. So now they take like kind of 8 minutes presentation. So we have like 7 minutes more to talk about their presentation right now. So like that. So yeah, I mean, like if there is any questions, I mean, the comments. If there is any comments, yeah, please. So did you hear me from there, like in June? Hello, can you hear me?
Yeah.
Okay. So any comments for this team? Anything is fine.
I have a very, can you hear me?
Yeah.
Yes, thank you for presentation. And I have a very quick question. How would you cooperate each other's projects later on? Do you have any plan for that?
So the idea is that we grouped each team with 3 different functional morphology types, and they would hopefully they'll have different morphologies per function, or like various morphologies per function, which will be 3 different types, and kind of use them together to create a building design or architectural design. I think what's, yeah, sorry.
I think I missed some of like images from the slide. Could you go back to the like result from the like flooring and structures part? So like my kind of understanding was like when you input your some like data first time, like the previous step, because the data itself is somehow look like from when I understand like Roy's presentation, like each elements are kind of really basic and kind of showing the like typology for the like really as it is, but when you put in like some data in, it comes out like something. I cannot imagine how it's gonna be like for the flooring, or it doesn't seem like typical. So I think it's kind of interesting part, and I'm so curious about like how we're gonna manage for the next step as well.
Yeah, I think it's also quite difficult to see what kind of functional morphologies will be derived from different runs, because we just didn't have enough time to run the data set. But I think by almost identifying, common denominator of different 3D models and how they convert to space, I think it would be super interesting to see what comes out. We actually don't know exactly what we were expecting.
So in that case, like for the result wise, it doesn't need to be flooring itself, right? Because like after when you merge it together, it somehow like there is no boundary between like this flooring and also structure wise is kind of like merging together all of each element, no?
So in terms of flooring specifically, I think students kind of try to identify almost like a codifying method, right? So if you have the flooring, you will have kind of defining elements that set the boundaries. So those would be the wall, the columns, and so on and so forth. And then I think whatever comes out, you'll still have some kind of arrangements for the flooring and different positions of columns and walls is what I'm kind of like guessing, right? Which will give you how these spaces, how in most the spaces were configured. I think it's like a probability kind of thing.
And I think actually, so when we divide all these the functional elements, we just decided to use the 4. So for example, like we suggest them the opening, not like the window or some gate or some the ventilation itself. So that abstraction means we wanted to just define some more the general functional something. So this give us more some the broadened perspective, like, and then it also gives some the new room to combine some of the different elements more easily, so that some of the new like architectural typology or some of the spatial quality could emerge from it. So yeah, actually we don't know like what the asset will look like, but yeah, we are just investigating some of the new architectural morphology by the function.
Hello, my name is Sanju Kim, and I'm the first speaker of our team Yellow for the Unit 4. And as you can see, my element that I chose was canopies, and I intend to rediscover the functions of canopies through this project. So first of all, we had to come up with our own definition of a canopy. And I thought a canopy is like a roof, but it has a more temporary aspect to it. So in my definition, I decided to say that it is something that creates a shaded exterior shelter below for a temporary stay, unlike roofs where it's usually a solid structure that is usually permanent. But in this case, canopies can be for a more temporary stay. And to reflect this kind of objective, I thought it should, in speaking in form terms, it shouldn't be bounded by more than one surrounding surface wall. So usually, in my terms, a canopy is supported by poles or a single wall instead of being surrounded by several surface walls. So this was my own definition of a canopy. And so we had to collect several canopy data from Korea. And as you can see, there are several types of canopies that you can find in Korea. As you can see in the images, from traditional Korean architecture to apartment entrances to tents and sunshades and entrances for several bus stops or subway stations, they could all fit into my own definition of a canopy. So these were some of the references that I used. And we had to 3D model all of these references. So as you can see, I came up with my own data set through 3D modeling. And some of these models include what I mentioned right before, subway entrances, bus stops, and whatnot. And we use all these 3D models and we input them into the machine learning algorithm. And these are some of the samples from the total of 450 samples that the machine learning came up with. And from these samples, we were able to come up with some outputs from the machine learning. And as you can see,
The most common aspect is that they are all levitating mass or surfaces above ground. And in cases of sample 8, 9, 10, you can see there are some a few aspects that are trying to form a type of pillar so that it could support the levitating mass or surface. So I guess this could be the acting function that the machine learning has learned through all my generated data sets. And we could come up with several ways to present how the machine learning generated. So in this case, we used the grasshopper algorithm so that it could kind of make it more smooth instead of a voxelized pixel version. If you kind of compare with the other slide, this is a voxelized pixelized version, whereas this one is a more smoothed out, so that it could kind of look as a more fluid form. And finally, we could interpolate all the sample data so that it could come up, so that it could create less discrepancies between the sample forms. And this could be, it could be turned into a GIF as following.
Hello, my name is Yusora, and Unit4 and flooring is my subject to research and progress. First, I define flooring. That's what I think. Flooring is empty and flat space that mediate indoor and outdoor spaces. Here, I found some elements that function as flooring in Hanok. The Chongmaru usually means the biggest floor. A part of the wall is open, so it is a space that functions for outdoor and indoors. Next is Numaru, which is a space that is more in contact with the wall outside than the Chongmaru. It is the buffer space for willing to be installed around the floor and where people rest in the sit in. It is the characteristic of Tenmaru. The outside of the floor is usually opened, but it is also in the form of the hallway in modern building and attaching windows. Chongmaru refers to the floor made by attaching a surface to the outside of the pillar, a structure in which one side relies on the building and the other side is supported by short pillars. Flooring created by Piloti is a narrow and long spaces where people can movements take place. A parkour or balcony could be found in Hanok. It is a space where you can experience external space on upper than second floor. Elements of this image is the data and of the element that function is flooring, which I explained. Make the modeling data based on my own definition. Next is the image that set up in modeling format and extracted some forms through machine learning. These several images set as modeling spaces. It seems to tell the meaning of the floor and show the shape of the interior space, the wall of the exterior space, and the elements of the railing connect to the floor. I think it is a process of the finding of form that reflect the flooring function.
Hi, I'm Jian, and I start presentation. Opening is defined as a boundary that separates the outside from the inside and as an open space between elements and elements. Openings are void in a world such as a window, doors, or even niches. And my definition of opening is an open space between elements and a passage light people and scenery can go through. I collect more images that fit the definition of opening. Demon is first opening to the enter the hanok. The gate of hanok are characterized by different shape depending on the owner's data. Second opening is frame. The frame is an element of the opening seen on the model. And third opening is window. The window passes through light and scenery. Next is window and door. The door passes through people as well as light and scenery. And last is corridor. This is 3D modeling of the opening, and this is training results. All have the common that there is an open space between elements. Thank you.
Before anyone comments, can I just quickly say one thing? So I think it's quite important to look at how students define their what students define their function to be, which is kind of like an act of narrowing down certain logic system in how the functions reflect into form. So that, I think that was actually what a lot of students worked or spent a lot of time on, and how those were also converted into a comprehensive data set to give forms and for the machine learning to pick up different probabilities. And it's really a lot of kind of like a logical thinking behind. So I can, yeah, it's quite hard to have like a general kind of conceptual architectural talk about it maybe at this stage, but maybe if you can look at, you know, how students made that conversion would be also quite helpful. Thank you.
I have one question, please. More of a general question, maybe a question for the tutors. So just to, they have a canopy, they have deck or bottom, and they have opening. And maybe this will be the next step, but I recall maybe the connection between these three elements will be the key when it comes to the final result. And we call the connection with the term detail or structure or whatever. Because if you see the outcome, which is processed with all those data sets, maybe canopy, deck, and opening might not match with each other. So I'm curious how, because in the end, correct me if I'm wrong, it will be aggregated into one building. So what happens when it doesn't match with each other? I'm just curious.
I think, sorry, so are you wondering how these different so-called functional morphologies would come together, or? So I think that's where the role of the designer comes in, because we kind of try to retain this position of designer as a curator of data, first of all, and then also being able to implement that data or the resulting data into design. There isn't, there isn't a particular methodology that we developed yet, because we don't actually know what kind of data results we're going to get as well. So that's quite a tricky part, but I'm sure we'll be able to find some kind of logic system that can work to combine different functional morphologies.
Yeah, when you mention the functional morphology, I'm really expecting like the whale, like whale has a normally they have an arm, but it becomes like a fin, right? But the whale is mammal, right? And then the fish, they also have a fin, right? But it's not come from the arms, right? There's a different root, but the same functional result, right? So I don't know, but we using like a neural network kind of machine learning thing. So if you put some data set, but the starting point is all different, but might be there reached a certain, same end result, the functional result will be questionable. It is a normalized scenario. But at the moment is you dealing with you find out on this quite low resolution. And then the voxel 3D gains is quite difficult to read out what kind of the significant point and come out. So that's why I've been like wondering how deal with that, and you think. I don't know where we're going. I'm not sure whether you have it or not, but so functional morphology means like something evolved somewhere your data set, but at the moment it's quite difficult to read. That's my
Sorry, it's really difficult to understand when someone speaks from the room, because I think maybe there's a lot of echo or the mic is not great.
So actually we started our training last night. So we don't have time to actually train to create like very high resolution and some meaningful results. So this is just like first trial, and almost like possible trial error. And then so the next step should be like how we sample some like very architectural usable from the geometry in the latent space, and then how we also pre-process it, process it to actually make it more the architectural usable elements. Also give them the chance to easily merge together with the different elements like support to canopy or the opening to the support system. So in short, so actually we're like in progress. So we're just gonna be like better, and also we're like investigating on like what the output should be, and then how these different the elements could be merged together to create some new spatial the architectural quality and some of the undisclosed the morphological features.
So also just to add, so for instance, if you have a corridor which serves a very specific function, you can have a Victorian corridor and you can have a Hanok corridor. In Hanok corridor, you have more openings around the corridor than the Victorian one, because one is more internal and one is a condition between the inside and the outside. And I think the machine learning will be able to kind of pick up on that condition, and just having that finding and implementing into design will be a valuable kind of reflection of some kind is how I imagine it, if I understood some of the comments correctly.
All right, thank you. So, I mean, anyway, we have two more teams. So I think, Jimmy, were you talking about, did you want to talk about this team or in general of ours in the?
In general.
Okay, then after, yeah, we go, okay, since because of time, we're going to do the two teams in a row, and then maybe we can talk about, because since it seems like all of your comments is about your general, our unit agenda, so I think it's fine to do with your two teams in a row. All right, thank you very much.
Hi, I'm Lyong from Green Team, and here's my team members, Eddie and Isabel. So we're gonna focus on Korean traditional elements in architecture. And I'd like to talk about my definition of opening. And I defined opening as a medium through which one thing moves across one side to another. So here's an image that shows my definition of opening briefly. So in my project, I'd like to redefine the meaning of opening from a building's perspective beyond human-centered thinking. So on the left section, these are the opening elements that people define in the building. And it includes doors, windows, or something along the line. And on the opposite section, I think it would be the opening elements that buildings define by themselves. So particularly, I'm gonna focus on opening for air. And in my definition, there are Korean traditional chimneys that have diverse shapes of holes. And we can see on Korean modern apartment chimneys, which is familiar. And these are abstract shapes of chimney. And these are the 3D GAN image. And these are the voxelized image inside the chimney. And in this space, we can image diverse void that have not been seen from humans' perspective.
Hi, my name is Eddie. I chose support as an element. And to start with, according to Oxford Dictionary, support is defined as a thing that bears the weight of something or keeps it upright. But from my perspective, support you can see in Hanok not only bears the weight, but also work as a device that connects the inside and outside based on the grid. Therefore, I define support as an element utilized within the primary grid of the building system that also create a fluid boundary condition between the interior and the exterior. The void that forms between the columns work as a frame connecting in and out of Hanok. Korea has traditionally emphasized exchange with nature. According to my research, the role of pillar based on the grid strongly served as a void for communication with the outside. And I researched and collected the data. Voice for internal and external communication along with the pillars of the grid system is quite common in Korea, especially street market in Jongno or Jeongja in an apartment, bus stop, or even in other architecture. After identifying the relationship between the grid and the columns, the categorization was carried out by the number of shape and size of the column and the shape of the grid. The representative type that you can see in the right has defaulted on the most basic form of the number of columns within the grid. And then I made a new variation based on the data. Based on those 3D data, I started training process of 3D GAN, and this is the Hanok support shapes based on grids synthesized by 3D GAN. And in conclusion, I explore a functional morphologies with 3D GAN. I selected morphologies that can emphasize a continuous sequence of inside and outside, which is produced by columns, walls, and floors.
What we can see is that the inside and outside are distinguished by the generated pillars and walls, but the inside and the outside are connected through the void between them. Therefore, this process gives us a potential expectation of a new morphology, and we can expect and find a new pattern of architecture, which emphasize correlation of column and grid, providing a connectivity of inside and outside. Thank you.
Hi, everyone. My name is Isabel, and my element is canopy. So I started by asking myself, what do I define a canopy as? So instinctually, I think of things like tents, awnings, bus shelters, but also tree canopies, cloud canopies, the canopies that form from seaweed under the ocean, things like that. So all of these kind of typologies in this initial data set to me are canopies. And from this exercise, I started to realize that I defined a canopy as something definitely distinct from a roof in that it's pretty much independent from a building superstructure, and it has often a temporality to its usage. Underpinning all of these examples is that they have the function of providing shelter, most importantly. So I therefore define canopy as an overhead projection with the primary function to cover and provide shelter rather than to enclose. So from this, I then had another go at research looking at specifically Korean architecture. I'm relatively new to Korea, so I did utilize Google Street View a bit to explore a variety of different urban conditions in a couple of different cities. And that allowed me to gather some data reflective of Korean urban canopy morphologies. One that I just want to highlight is the example of the green awning. It's pretty unique. I've never seen these before, and they're everywhere. They're made out of a semi-transparent green awning, sort of green glass or plastic material. And even though they're the same color, it's interesting that they are all relatively different in form, and yeah, that they occur in such a wide variety of areas. And the more you look, the more you will find. In addition to that, I also started to group the kind of canopies that I saw across the data set into 3 broad groups. So canopies that are for sheltered walkways, stairs, streets, escalators, umbrella or tent-like canopies that provide a sort of central covering, often freestanding, and then awnings or eaves such as those outside the front of shops or at the interface of market stalls. And so each of these facilitate a similar but different kind of function. So to start the 3D GAN process, I began by modeling these different kind of canopies in Rhino to build up a 3D data set. And then to prepare these geometries for processing, they were voxelized. So far, as I've been doing this, I've realized that not all of my models have been properly converted into voxels. For example, in the middle, you'll see there's nothing because the geometry is just simply too small or too thin. And the reason I included this is just to sort of demonstrate the kind of challenges that I and my unit will be facing in utilizing this methodology, in that the inputs that we start with or generate will need to be sort of worked on quite a bit. So yesterday I did a trial run using in 3D GAN using some of my simple canopy for like bus station kind of canopies. And yes, it was just using a handful of models. As you can see, the same issue with the voxelization occurred where my geometry was just a bit too thin. But that was what I started with. And funnily enough, even with that small amount of inputs and with the small amount of voxelization that I was able to get, you can actually see the process starting to work after running for 200 epochs. The sort of short linear elements that were in the previous slide do start to appear out of 3D GAN. So early days, but I think this shows a lot of promise that novel morphologies will be able to be synthesized using 3D GAN. Thank you.
Oh, okay. Hi, everyone. We are the red team, and my part is support. When the support comes to my mind, I found it fascinating that the tenon and mortise structure in the traditional timber structure architectures are really interesting. So next page. I found there are the tenant and multi-structures developed from the Asian architecture to more contemporary architecture. And it both shows the ability that individual elements can join together in a certain manner to achieve stronger resistancy and greater continuity. So I'm trying to explore how the volumes changed in those joints. Next page, please. So I modeled several joints in different forms. Next page, please. There are like different ways of the joints, and the forms are more like the posts and the columns and the beams. Next page, please. And next. There are also different forms in contemporary one. And next page. I set all the variations in the 3D GAN and let it learn, but I found maybe I still lack the contemporary forms variations. So it seems like the volume study still shows the spatial sense in the traditional joints. So I might explore more when adding more form variations in future.
Okay, sorry. Hi, I'm heading. My part is the flowing. I defined that flowing is an artificial surface that are localized by vertical architectural elements in top view, and a place where a person can take a basic posture rather than a place where people can do activities. So based on it, I selected two elements, courtyard and rooftop, because it's surrounded by architectural elements, not the indoor space that we often thought was the floor. First, courtyard is 중정 or 뜰 in Korean. It's outdoors and empty, but there is a surface surrounded by walls and columns, and people can stand, sit, and lying down here. Rooftop is 옥상 in Korean. It is outdoors and empty too, but there is a surface surrounded by low walls, and it is used in various ways as a park or resting space. So I modeled several types of elements. These are courtyards and rooftops. And based on it, these are my outputs. And I think some of empty parts are courtyards void or space between courtyard and rooftop. It is still in the beginning steps, and I'll be added to find out the fundamental form of flowing. Thank you.
Hi, I'm Minji from Unit4. I research about opening. My definition of opening is element or assembly of elements that frame openness in or between things, which gives a sense of expansion and openness for user. I classify this meaning as temporary opening and permanent opening. Temporary thing can be often then shut. Permanent things are often all the time. Model could be belong to both categories because some kinds of model consist of columns and doors. So sometimes it could play a role as a room. 툇마루, 쪽마루, and 누마루 consist of columns. So these elements all often all the time. And these are images showing function and form about elements. These are 3D modeling for machine learning.
Before midterm critic, I chose door and corridor. I made 98 different doors and 12 different kind of corridor. Using 3D GAN, I got these red images. I'm not sure that machine learning learn the features of doors and corridors well, but we can see some of these features of door and corridors. These are voxelization images. It shows diverse transformation. In the next step, I will make the other element 3D model. In this process, I want to find valuable discoveries related to functional morphology. Thank you.
Yeah, thank you. I think that's end of our presentation. So yeah, I mean, like if you have any question, I mean, discussions or comments, yeah, please. Yeah, sure, please.
Like, continuing from the last question I did, like the thing is great. In terms of like you guys are all the all the like column and or those things are having like really strong functions, and also the research from the students are like talking about like joints or translucent canopy, like those like that. So that is like already containing like so strong function, and like, but when you put it in that like style like GAN, the result comes out like it feels like sometimes like losing all the functions and all research and definition you did it before. So my confusing was like, is all this process was looking for like ideal types of the like, for example, like column or ideal shape of the column, still keeping all the like functions you defined at the first step, or is it just like making a new kind of shape from the input data or something?
I think maybe it can be the most, we're looking for the most probable shape in a specific culture rather than, yeah. And the reason why, I mean, we are expecting much more defined and much more defined morphologies as we do more machine learning and as we put in a lot more data, because we had probably about half, like one day, maybe not even that, to be able to do all that. And that's why the results are also not very clear.
How are you defining the pixel resolution? Right.
So yeah, so the pixel resolutions just already defined in the training process. So like 64 cubes or like 108 or 256. So, but when we just increase just the resolution 2 times, but the computational resources like increase like exponentially. So we are just like always on the trade-off. So yeah, so we just service them the task with the 64 resolution, and then after that, if we need some more need to like observe some of the detail or some more need some high resolution, we can definitely try the increased one like 128 or 256 or more and more. And then in terms of yeah, go ahead.
So no, go ahead.
So, and then in terms of the previous question, that's like also like confusing one. So we collect some lots of the elements and then train the machine. So you guys like think that, oh, there could be some the ideal shape or like some canonical one that can just explain the whole the system. But the actual thing is like, so we collect all the elements and the machine they learn all that the features and then also recreate all that variation in that machine. So it's more like learning all the variation. So what you can see here is only just the one sampling. Like when you think about the support could be defined as like column or like very long column or thin column or thick column or even like very long the loft or beams or something like. But when you just present it in the 3D modeling, you just pick just one sample like some column or the thin loft. And then the example students show here is also one of the samplings from the neural network. So the next goal could be like, like opening also have lots of the variation, and then machine also learn that kinds of the variation. And then we could define their own story. Like we could define our own story, like the support could merge with like the opening, and then we need some specific like that the functional elements, and then the machine learning gives us some like that chances to find that the geometry in the latent space. And then the main strength of the artificial intelligence is that we could interpolate all these variations sequentially. That means we could also observe or the transition between the column and column, not the canopy and opening, just column and column and like column and column. But this the transition also give us some the interesting like moment to make some morphological changes. And then also it also creates some like maybe like different functional usage kinds of. So that's what we also wanted to achieve here.
So I think my suggestion would be just to treat the resolution as a deliberate choice, even though I understand there's a computational limitation on it. But you make a choice to set the grid at a certain size, and if the grid gets large enough, then, or the pixels get large enough, then every column starts looking the same across all the projects, across all the cultures. So what is the sort of smallest this grid can be and still show uniqueness while also still showing sameness?
I have a few questions about the whole workflow, and just now I feel like we know the training process for 3D is pretty heavy and pretty long. And so what will be the ultimate goal for this 3D platform? Like for in this studio, like is it specific for like Seoul, Korea, for area, or it will be more general tools like Midjourney can generate anything from there? Because for example, if we are doing a specific like building design, then we need to find like all the features of that building, and we start to train final variation. So would this be like more like universal tools for everyone to use, or be more like specific to specific topic? And then whenever you need a new goal, you need to restart the whole process again. Just what would be your vision to think about this tool in your studio?
So I think the methodology is like pretty general. So it can be applied to architecture or even like furniture design or like whatever, like airplane or cars or whatever. So I think the methodology is like pretty general, but we as a designer, we just wanted to more to focus on the specific, the target. And then whenever I do some the machine learning, the most hard problem was that it's a little bit hard to understand the result, because I didn't like confine some of the area. So that's why we started with some the Korean traditional architecture. So this limitation also give us some the little like narrowed down but it also give us more the target. I mean, let's say the intended result. So we will be able to like maybe more the easily find some the patterns or some, yeah, that kind of stuff.
And so in that case, for so let's say now we have a specific goal for a specific topic, and so in your studio, like we know now we only train 1 day. So how many days or how many data do you think you need in order to achieve what you want for your project right now?
So actually, I'm like pretty like expert of the 2D game, not 3D game. So it's like also like one of my the experiment. That's also what I wanted to know here.
Okay.
Yeah. So like I don't know. So we just start like 2 hour, like 3 hours training, like with like 100 or 50 data.
Yeah.
And then based on the result, we could also like increase the number of the data size or some the training time or like much like better the computer resources and so on. So yeah, I don't know, but yeah, that's what I also wanted to know. Yeah.
And do you think a sample in the style is more important or a sample in the function of the space?
Sorry?
Sample in the build now, like a go say the joint, because it is visualized. So the joint, the detail of the joint is being like changed because of the resolution. And so I feel like now it's really hard to really sample the real meaning of the object. So more like we are studying the style of the.
Yeah, so yeah, that's also like good point. So the every element could might have some different size in terms of the size. So let's say, for example, one student choose some the collection of the columns. So the general size of the data set is pretty large compared to the other students. For example, some the small joint or some only like the opening. But the key part is that all the individual students maintain their on the scale. So there should be some lots of the window size or some the opening size, but by maintaining the one single the size, they can still find some even like the morphological feature of the size. Yeah, so that's also like pretty important part, like how we deal with the scale.
I'm just curious, would be helpful if we train like 2 elements together, like a window with a floor, because it's kind of start to inform space, and maybe they have like relationship between two. I'm not sure if that's.
Yeah, so we couldn't traverse 2 different latent space. So I think there could be the 2 options. The first one is we could just combine the 2 different elements into one and then train it and then generate the result. But I think it's a little like, I think it's not that good much. So I think the second methodology could be just train the model separately. And then actually we also like, yeah, just researching on like how we just deal with the different latent space, but into like in just one some general the geometry form.
And if I may add something, I think it's we will probably, as we go through different modeling and data collecting processes, we'll probably figure out what elements need to be integrated and removed. So like, for instance, if we're looking at the corridor, maybe we start removing the columns because they're distracting, or, you know, I think it's a lot of trial and error, but what we're essentially trying to do is, if you have models of chairs from specifically the UK and the models of the chairs specifically from Korea, they will look different, you know, after running machine learning. And it's that specificity that is quite important to us. And I think if you start using these different variations of different cultural kind of like data sets, you will eventually reach certain kind of design methodology that is somewhat fruitful, is my my comment.
Apologize for the delay, but allow me to give a final comment. I think the work is very exciting. I feel like learning from the history of 2D image-based AI is a matter of time. The resolution will go up, and it's a matter of time we'll get a really realistic model of 3D model. But also thinking about those like very fuzzy 2D images when we didn't have like Midjourney, I think we were also using images in a very different way than Midjourney. So I think now maybe it seems like, oh, we are not in good. It's just because of the lack of tools, development of tools. So it's only this resolution. But I'm going to design something as a placeholder. Instead, I think you can use literally this as a push for certain interesting aesthetics, or develop an interesting modeling methodology using this tool in this resolution. And for example, maybe replacing voxels with some actual geometric materials, and then to find a way to kind of translate and understand this like fuzzy, unclear, gooey, and low-res information into something readable, tangible, and visible. And then just try to kind of come up with some kind of really interesting modeling methodology, which might not end up like every time giving you that correct function. So maybe even if you design the canopy, maybe it doesn't give you an actual standing up canopy. I think that is still fine because it is an interesting way of being creative. So I feel like that function, that keyword of function might be a little problematic if you are designing a canopy and then you are trying to get a canopy, and very likely it's not going to give you a canopy. So you can use canopies as the input, and maybe something came out of it. It is maybe a architectural element. We utilize them, of course, in architectural scale, but we should reinterpret that and we understand it and shamelessly use this tool to design something really good. Yeah, so that's my suggestion. Thank you very much. Yeah.